Hello, everyone. Welcome to the lesson on smart contracts. Let's kick things off as usual with a quick quiz question. Which of these best describes a smart contract? Is it a function that transforms input to a fixed length output? B, a computer that maintains a blockchain network? Or C, a type of program that runs on a blockchain? Go ahead and pause the video for a moment and drop your answer in the comments below. All right, ready? The correct answer is C. A smart contract is essentially a program that runs directly on the blockchain. And what makes them so powerful are the special features they have built in. Let's take a closer look at smart contracts. Okay, now that we know what a smart contract is, let's look at what we'll learn and cover in this lesson. First, we'll talk about the key properties of smart contracts. These are built-in features that make them powerful and reliable, things like trustless execution, transparency, atomicity, and more. Then we'll explore some real-world use cases. Smart contracts aren't just theory. They're being used in finance, supply chains, gaming, and many other areas. This will give you a sense of why they matter outside of technical details. Finally, we'll see how smart contracts actually run on a blockchain. This will connect the dots between the code developers write and the way the blockchain executes the code securely. By the end of this lesson, you'll not only understand what smart contracts are, but also why they're important and how they work in practice. Let's start with some key properties. Smart contracts are more than just bits of code on a blockchain. They have special properties that make them powerful and reliable. These features explain not only how they work, but also why they're so useful. First, there's trustless execution. With a smart contract, you don't need to trust the other person or rely on a middleman like a bank or a lawyer. The smart contract itself enforces the rules automatically. Think of it like a vending machine. You put in the right amount of money and it delivers a snack. No questions asked. Next is transparency and auditability. Because smart contracts live on a blockchain, their code is visible to everyone. Anyone can check what the contract is programmed to do, and every action it takes is permanently recorded. It's like an open book that not only shows the rules, but also logs every move that's made. Another key property is atomicity. In blockchain terms, this means actions either happen completely or not at all. If part of the transaction fails, the whole thing gets canceled. It's similar to an all or nothing rule. Imagine booking a flight and a hotel at the same time. You don't want one to go through without the other. Then we have composability. Smart contracts aren't isolated. They can call and interact with one another. Developers can combine smaller building blocks into larger applications, like snapping together Lego pieces to build something bigger. Finally, there are gas costs. Each action a smart contract performs comes with a small fee, usually paid in the blockchain's native token, such as ETH on Ethereum or SOL on Solana. These fees prevent people from spamming the network with endless or overly complicated operations. Not every blockchain calls it gas, though. For example, Solana simply refers to it as a transaction fee. So, when you put all these together, trustless execution, transparency, atomicity, composability, and cost controls, you can see why smart contracts are such a foundational technology in blockchain. Okay, smart contracts aren't just an interesting idea, right? They're already running applications on the blockchain today. Let's look at a few of the most common examples here. One of the biggest areas is decentralized finance, or DeFi. These are apps that let people lend, borrow, or swap tokens without going through banks or brokers. For instance, lending programs like Aave allow users to earn interest by lending out tokens, while decentralized exchanges like Uniswap let people trade tokens directly with each other. Staking is another common feature where users lock up tokens and earn rewards over time. All of this is handled by smart contracts instead of financial institutes. Another major use case is the non-fungible tokens, or NFTs. These are unique digital assets like artwork, collectibles, or even in-game items. Smart contracts power the entire NFT process, from minting new tokens to automatically sending royalties to creators to running marketplaces where NFTs are bought and sold. We also have decentralized autonomous organizations, or DAOs. These are groups that use smart contracts to make collective decisions. Members hold tokens that represent voting power, and the smart contract automatically counts votes and carries out the group's choices. It's governance without the traditional management structure. Beyond these, smart contracts can be used in many other ways, like holding funds in escrow until conditions are met, tracking goods through a supply chain, or even selling event tickets securely to prevent fraud. Some smart contracts aren't just theoretical. Actually, excuse me, not some smart contracts. Smart contracts aren't just theoretical. They're already reshaping how people interact with money and ownership and organizations. Now let's talk about how smart contracts actually run. For this, we'll use Ethereum as the main example. A smart contract doesn't just run on its own, it needs someone to interact with it by sending a transaction that calls one of its functions. By default, contracts can't act on their own, although services like Chainlink Automation can be set up to trigger them on a schedule or when specific conditions are met. There are two main types of operations. Read operations, like checking someone's balance, are free if you run them locally and don't make changes to the blockchain. Write operations, on the other hand, actually update the blockchain, and things like sending tokens require gas fees. Every transaction also sets a gas limit, which is the maximum amount of computational effort you're willing to pay for it. If the contract tries to use more gas than that, the operation fails and the blockchain cancels all changes. This is the all or nothing approach that we mentioned earlier. Can you remember what concept that was? Let us know in the comments below. All right, here's what the process looks like step by step, typically on Ethereum, right? So first, the network validates the transaction, checking the signature, nonce, and whether the account has enough balance. The system deducts the initial gas, so you pay up front for the processing. It checks permissions to confirm you're allowed to call the function. Then, the contract code is executed. The gas is consumed as each operation runs. The contract state is updated, which means the blockchain data is eventually modified. Events are emitted, which is how contracts log what happened so external applications can respond. And finally, any unused gas is refunded back to the sender. So in simple terms, smart contracts run when you poke it with the transaction. The blockchain checks that everything is valid, runs the code, charges you for the resources used, and either completes the transaction or cancels it entirely if something goes wrong. Okay, to wrap up, let's quickly summarize what we covered today. Smart contracts are programs that run on a blockchain, and they have several key features that make them powerful and reliable: trustless execution, transparency, atomicity, composability, and cost controls through gas or transaction fees. We also looked at real-world use cases, including decentralized finance, NFTs, DAOs, and other applications like escrow, supply chain tracking. Finally, we explored how contracts run, how transactions trigger their functions, the difference between read and write operations, and how Ethereum handles execution step by step. Now it's your turn. Pause the video and type in the comments below. What is one thing that you learned about smart contracts today? Was it a property, a use case, or something about how they run? I'd love to hear your thoughts. Thank you for watching, everybody. Let's keep learning. Head over to our website and get the full lesson and take the quiz to test your knowledge. The link is in the description below. We'll see you next time.